This is your video for section 7.3. This one's about the law of cosines. This is the law that we use in another case where we can't use the law of sines. This would be when we have two sides and the angle in between them. So this would be for the side angle side case. Here's the formulas for the law of cosines. And again, with these, I would really recommend that you don't try to just memorize these formulas. Just memorize the form. What always happens is that for the angle over here that you're taking the cosine of, you've got its corresponding side on the other side of the equation. So you've got this side over here squared, and then you square each of these two sides, and then minus 2 times the product of those, and that's times the cosine of the angle that corresponds to this side over here. If you can memorize what that format is, then you don't have to try and memorize all 3 of these formulas with all the different letters in them. Let's look at some examples of applying this law. In this one, we've got an angle C, and we have the lengths of these two sides, A and B. What we're trying to find is the distance C that goes from A to B. So what we have here is a side angle side. What that means is that we can't use the law of sines because we don't have an angle and the side across from it anywhere in our given information. It's much easier to use the law of sines, so we use that one whenever we can. If we can't use the law of sines, then we use the law of cosines. Since we've got the angle C, the way we're going to set this up is with this third formula right here. We're actually trying to find side C. So on this side we've got C squared, and then over here we're going to take our other two sides and square each one, add those two things together, and then we have minus 2 times these two sides, A, B, and then we have the cosine of angle C. Now we can plug in all the information that we're given in on this side. Now you can see that this formula is a lot longer than the one for the law of sines. That's why we don't use this one unless we have to. One thing to watch out for is that when you plug all of this stuff in, what you end up with is the side squared. So then your last step has to be to take the square root of both sides to get the actual length of the side. And be careful if you're plugging this in pieces that you make sure you do your order of operations properly. So you want to do the squaring first, and then the multiplication, and then the very last thing is to do the subtraction. On this one, if you plug everything in on this side, you get an answer of approximately 394,510.57. That's for the C squared, so then you're going to take the square root of both sides. That's going to give you C, which is going to be approximately 628. Since these measurements in meters, then that's in meters. So our distance here is going to be 628 meters. Now, the same thing holds true for this as it did when we were talking about the law of sines. Since this is the biggest angle, it's the obtuse angle in the triangle, then this has to be the longest side in the triangle. Here's another example. In this one, we're solving the entire triangle. And we don't have the picture, so we're going to have to draw this ourselves. Now this one, it doesn't matter really which way we draw the picture, as long as you make sure that your angles are across from their corresponding sides. So if we want to put angle A over here, that means that our side A would be over here. There's my picture. Now I can see what to start with because I need to find 3 different quantities. I need side A and I also need angle B and angle C. I can't use the law of sines because I don't have anything where I've got both the angle and the side across from it, and I only have one angle, so there's no way to get either of the other 2 angles right off. So I'm going to use the law of cosines. The 2 sides I have are B and C. I can use my law of cosines to find a squared. Since my two sides that I have are b and c, then those are the sides that are going to go on this side of the formula. My angle that goes in here is going to be the one that corresponds to this side, so that's going to be angle A. Now I'm just going to plug in my values. Then I'm just going to work this out. I put this all in my calculator, all in one line, and that turned out to be 109.7 for my a squared. Then I'm taking the square root of each side. That's going to give me approximately 10.5 for my a. Now I've got the three sides. Now I need to find one of these two angles. At this time, since now I've got the side and the angle across from it, now I can go back to the law of sines. I'm going to use a over sine of a, and I'm just going to pick one of these other two angles to find. I'm going to use this to find angle B. So I would put in side B, and I want to put that over sine B. 10.5 over the sine of 42.3 degrees equals 12.9 over the sine of B. I'm going to solve this for the sine of B. That gives me approximately 0.8268. Then I would use the inverse sine to find angle B. The inverse sine of 0.8268 with my calculator in degree mode is going to give me 55.8 degrees. That's my angle B. Now that I've got B, I also have A. Now I just have to add those two together and subtract from 180 to get angle C. That gives me angle C is 81.9 degrees. Now I've got all three angles and all three sides. And I can check for reasonableness by making sure that the smallest angle is across from the smallest side and the largest angle is across from the largest side. This is another place where you can use the law of cosines, and this is if you have the side, side, side situation. Because in this case we don't have any angles. That means we can't use the law of sines, so we have to use the law of cosines. In this one, it really doesn't matter which one of those formulas you use out of the law of cosines. What you're doing is solving for one of the angles. So I'm just going to use the one with the a squared on the left side. And that means I'm going to be solving this for the cosine of a. And I do want to be careful when I go to solve this for the cosine of a. First, I'm going to have to subtract these two values from both sides. So really what I'll have is a squared minus b squared minus c squared on this side. When I put this in my calculator, I get negative 608.3391. And when I multiply these three values together over here, I get negative 670.98. Now I'm going to divide both sides by the negative 670.98. That's going to give me 0.9066, and that's going to equal cosine of a. Probably the hardest thing about doing this type of problem is just getting the algebra part right. Now I can use the inverse cosine to get my a, and it turns out that a equals 25.0 degrees. Now that I have the a, I can use the law of sines to get angle B, and then once I have angle B, I'll have two of the angles and I can easily get the third angle. So to find angle B, I'm going to take side A and angle A, which I now know. So this is A over sine A equals b, which is 15.9 over the sine of b. If I solve this for the sine of b, I'm going to get 0.7096. Then I would do the inverse sine to get my b, and that turns out to be 45.2 degrees. Then I can take my two angles that I know, add them together, and subtract from 180 to get my angle C. Turns out my angle C is 109.8 degrees. That's an obtuse angle. This is the largest angle, so it should be across from the longest side. If I look at my three sides, side C was the longest one. My smallest angle was A, and my shortest side was A. One more example. In this one also we have three sides, and we're just trying to find one of the angles in the triangle. Since we want to find angle B, that means we want to set this up so that we have the formula that has cosine of B, so that we can solve for angle B. That means that on this side of the formula we want to have the B squared. So over here we're going to have A squared plus C squared minus 2AC times cosine of B. The B is 6, the A is 11, and the C is 9. So just like in the last one, I want to solve this for the cosine of B. So first I've got to subtract these two quantities from both sides. This is going to be 36. 11 squared is 121, so I'm going to subtract that. 9 squared is 81. So I'm subtracting those things from both sides. I squared each one of those first before I subtracted that. If I work this out, this is negative 166. On this side I have negative 198 times the cosine of B. If I divide both sides by the negative 198, I get approximately 0.83838, which is equal to my cosine of B. If I use the inverse cosine, I get 33 degrees for my B. In this problem, that's all we were trying to solve for was the B.